Hello everyone! Today's lesson is about solving word problems involving algebraic equations. Let's have some examples. First, the sum of a number and negative 25 is 45. Find the number. Before we can answer this problem, we have to translate it first into algebraic equations. So, recalling what you learned from our previous lesson, let us translate the sum of a number and negative 25 is 45 into an algebraic equation. And we'll have, let's represent that number or unknown number as x. Then the sum means we'll be adding that number and negative 25. And if we do that, the answer will be 45. In our previous lessons, you learned how to find for the value of the unknown number in a given equation. So that's what we will do in this equation for us to find for that number, which is x. That means we'll be transposing negative 25 to the other side so that we can combine it with this constant here. So we'll have x is equal to 45. This is negative 25, so when you transpose, this will become positive 25. Then we'll have 45 plus 25. That will give us 70. Therefore, the value of x is 70. So our number here is 70. For checking, we'll just have to substitute x with 70. So we'll have 70 plus a negative 25. Okay, let's check if that is equal to 45. This is positive and this is negative. Therefore, when we combine, we have to subtract. And 70 minus 25 will give us 45. Since both sides of the equation are equal, then the value of x which we got is correct. Let's try another example. This time, we are given the difference between a number and 13 is 75. Find the unknown number. Okay, so again, for us to find for that unknown number, we have to translate this problem first into an algebraic equation. It says difference between a number and 13 is 75. So when translated into an algebraic equation, we'll have x minus 13 equals 75. So again, for us to find for the value of x, we have to do transposition. So we'll have x equals, this will be transposed to the other side. So we'll have 75 plus 13. Therefore, x is equal to 88. Okay. Again, to check if your answer is correct, you just have to substitute this value to our original equation. Another one, the product of 4 and the number is 60. What is the number? Okay. Again, we have to translate this first into an algebraic equation. And when you translate the product of 4 and the number is 60, we'll have here 4 times x is equal to 60. Okay, again, since it states the product of a number, this is unknown, so I used x to represent it. You may use other letters, but for uniformity, I'll be using x all throughout our discussion today. So we have 4x is equal to 60. Then for us to find for the value of x, we have to eliminate this 4. That means we'll be dividing both sides of our equation by 4. And we'll be left with x is equal to 60 divided by 4. That will give us 15. So the value of x is 15. Now we have the quotient of a number and 9 is 27. What is the number? Again, we have to translate it first into an algebraic equation. So we'll have x over 9 or x divided by 9 is equal to 27. Okay, we have here a denominator. That means for us to eliminate this one, we'll have to multiply it to the number on the other side. Okay, then we will be left with x only on the left side. And 9 times 27 will give us 243. Therefore, the number we are looking for is 243. Another example, 7 less than twice a number is 9. What is the number? Again, we'll translate this first into an algebraic equation for us to find for that number. Okay, and 7 less than twice a number is 9 is translated as, okay, we will subtract 7. So we'll subtract 7 because it says 7 less than twice a number. Okay, when you say twice a number, it means 2 times the number, and that is written as 2x. Okay, so 2x minus 7 will give us 9. Now let's solve for the value of x. Let's transpose first negative 7 to the other side, and that will give us 2x is equal to 9 plus 7. Therefore, 2x is equal to 16. But we're looking only for the value of x, so we'll have to divide both sides by 2 to eliminate this 2 here. And we will have x is equal to 8. Therefore, the number we are looking for is 8. Let's try another one. The sum of two consecutive integers is 145. Find both integers. So in here, we are to look for two numbers. Therefore, we'll have to make representations. So let's say that the first number is x, since we do not know this one. Okay, we do not know any of the numbers, so we will represent one of them as x. Okay, then since it says the sum of two consecutive, there is a condition that the numbers are consecutive. So if our first number is x, it means that we'll have to add 1 to the first number to make sure that these two numbers we have are consecutive. Okay, yan. So again, say for example, the first number is 1. Okay, then the second number will be 1 plus 1, and that will give us 2. If x is equal to 7, then we'll have the second number as 7 plus 1, that will give us 8. Okay, so again, this is how we represent consecutive numbers. Okay, we add 1 to the previous number to make sure that the numbers we will get are consecutive. Okay, so let's have our first number is x, so we'll write here x. When the sum, it says the sum of two consecutive integers. If the first integer is x and the second integer is x plus 1, then we add these two. According to the problem, it will give us 145. Okay, so this is the first number and x plus 1 is the second number. Okay, so there are two x here. Then let's combine like terms. We have x plus x is equal to 2x. This constant here will be transposed to the other side, and that will give us 145 minus 1. Therefore, 2x is equal to 144. But we're looking for the value of x, so we'll divide both sides by 2. Then, x is equal to 72. Okay, but remember, we're asked to look for both integers, and x is just the first number. For us to find the second number, we'll have to substitute x here with 72. Okay, so we now know that x is 72, therefore 72 plus 1 will give us 73, and that is our second number. Okay, so our numbers are 72 and 73. Let's try another example. Mona bought 125 pairs of slippers to be donated to 2 barangays. She gave Y slippers to Barangay A and gave 60 to Barangay B. How many slippers did she give to Barangay A? Okay, so in here, we have to translate this one into an algebraic equation. Okay, so it is given that Mona gave a total of 125 pairs of slippers to 2 barangays. So we'll have here equals 125. Okay, she gave Y slippers to Barangay A. So it is given that the variable that we will use is Y. Okay, we do not know yet how many she gave to Barangay A, but it is represented by Y number of slippers. Then she gave 60 to Barangay B. That means when you add the numbers of slippers she gave to Barangay A, which is Y, and the number of slippers she gave to Barangay B, which is 60, the total should be equal to 125. That's why our equation here is this one. Then we will solve for the value of Y, because we have to know how many slippers did she give to Barangay A. Okay, that means we'll have to transpose 60 to the other side, and that will give us 125 minus 60. Then we'll have Y is equal to 65. Okay, therefore, she gave 65 pairs of slippers to Barangay A. Let's try another example. Bobby is 3 years older than Chris. If the sum of their ages is 45, how old is Chris and Bobby? So this time we're asked to look for the ages of Chris and Bobby. Okay, we are given that Bobby is 3 years older than Chris, but Chris' age was not given. Okay, however, we know that the sum of their ages is equal to 45. Therefore, we have to represent, again, the unknown value using a variable. So let's say first that x is the age of Chris. Okay, then it is stated that Bobby is 3 years older than Chris. So if Chris is x years old, then adding 3 to it will give us Bobby's age. Okay, you can also have it the other way around. If you want to let x equals Bobby's age, therefore Chris' age will be x minus 3 because he is 3 years younger than Bobby. Okay, but let us use the first representation. So let's have x plus 3 is equal to 45 since the sum of their ages is equal to 45. Then combining like terms, we'll have 2x is equal to 45 minus 3. Okay, so we'll have 2x is equal to 42, and dividing both sides by 2 will give us x is equal to 21. Therefore, Chris is 21 years old and Bobby will be 21 plus 3. That will give us 24. Okay, so this is Chris' age and this is Bobby's age. Let's check if we will get the same answer if we use this equation. So we'll have x plus x minus 3 is equal to 45. So we'll have here 2x is equal to 45 plus 3. That will give us 2x is equal to 48. Dividing both sides will give us 24. So we got 24 is Bobby's age. Then subtracting 3 to 24 will give us 21, which is Chris' age. Okay, so again, we'll just get the same answer. Either of the two representations can be used. Now, let's have our last example. The class of 6G donated relief goods to the people who are affected by the typhoon. The class of 6H donated twice as much as the class of 6G. If there were 345 bags of relief goods in all, how many bags did each class give? Okay, so in this case, we do not know how many bags did each of the classes give. Okay, that means we'll have to use representations. Let's say X is the number of bags donated by 6G. Then it is given that the class of 6H donated twice as much. So when we say twice as much, we'll have to double X. So that will give us 2X. And this is the number of bags donated by 6H. Adding the two numbers will give us 345 since that's the total number of bags donated by both sections or classes. Then combining like terms here, we'll have 3x is equal to 345. We'll have to divide both sides by 3 to get the value of x, and that will give us 115. Okay, therefore, the number of bags donated by 6G is 115. When you double this one, okay, so that means 2 times 115, that will give us 230. This is now the number of bags donated by 6H. And that's it for our lesson for today. Thank you for listening.